Okay, let's have a year 11. Let's have a look at some of these questions from exercise 511, these curve sketching questions. Question 5. Today in class, we did questions 5A and 5B, so I'm going to do a couple more to give you a hand with them to see if you can conquer these on your own, and we'll see how you go. So let's have a look at 5C. Now 5C is y equals x on x plus 1. Now the first thing to note, the first thing you should be thinking about is that we can't divide by 0, so x cannot equal -1. Let's let x equal 0, and we'll see what we get for y. And when we get y equals 0 on 0 plus 1, which equals 0. So I've got the x-intercept now, and I've got the y-intercept because they equal the same thing. And I've got x can't equal -1. I can try and find out whether it's even or odd, but just by looking at it, I know if I put a negative in the top and the negative in the bottom, that's not going to help me out, and it's going to be pretty ugly. So I'm not going to go down that path. Now I am in a bit of a trick here. I could find the horizontal asymptote. So let's try that. A HA, and the limit as x approaches infinity of x on x plus 1. Well, that's going to equal the limit as x approaches infinity, divide by the highest power of x, which means I get x on x, all over x on x plus 1 on x. Well, that's going to give me the limit as x approaches infinity of 1 over 1 plus 0. Oh, sorry, 1 on x. And that'll give me 1 on 1 plus 0. So I'm going to get 1. So I've got a HA when y equals 1. So what does that tell me then? I'm just going to erase that. I'm going to put it back over here a little bit. Well, that tells me that I've got it's going crazy now. So what do we get? Y equals 1. And I'll just erase that. Try and put another one in now. There we go. Now, what does that tell me? It tells me that I've got an asymptote at y equals 1 and another one at x equals -1. And I'm sort of out of options now. I suppose I could plot points or find out what happens as x approaches infinity and all these other things. But I'm lucky because I know a little trick. Let's have a look again at this equation and see what we can glean from it. And we know that y equals x on x plus 1. Well, it's not in a nice, easy method for me, but luckily I know a little bit of the polynomial division. So I'm going to do a polynomial division here of x over x plus 1. And if I multiply that by 1, I'll get x plus 1. If I do that subtraction, I'll get 0 minus 1, which gives me -1. So I can rewrite this equation as y equals, now because I've just done this division here, I'm going to get 1 minus 1 over x plus 1. Now this looks a lot like something that I already know. This looks like my standard hyperbola. And if I take that 1 over the other side, it means I get minus 1 equals negative 1 over x plus 1, which is a standard negative hyperbola. So it's going to look like that. And I've already got the asymptotes in there at y equals 1 and x equals negative 1. So now I can just draw it. And all I have to do is I already know that it goes through 0, 0. I've got these two bits. And there's the graph of y equals x on x plus 1. Knowing this little bit over here, how to do that saved me a lot of time. I could have plotted points. I could have found out what happened when x approaches infinity, both positive and negative, and I would have found that it approached 1, as x approached positive infinity, it approached 1 from underneath, and as it approached negative infinity, it approached 1 from on top. All right, let's have a go at another one. And I'll just get rid of this. And we'll look at 5 D and see if we can do that one. So 5D. Y equals x squared on x squared plus 1. Well, let's do our first bit. The denominator can't ever equal 0 because we've got a positive number plus a positive number, so that's already gone. But let's find f of negative x, and that equals negative x squared on negative x squared plus 1, which will give me x squared on x squared plus 1, which equals f of x, hence an even function. And that's really cool now because I only have to draw half the function and just mirror image it. Now, what else do I have to know? Well, I can find the asymptote, the x-intercept. I'm just getting rid of all this down here. I can find the x-intercept if I just let x equal, the y-intercept, if I let x equals 0, and I'll get y equals 0 on 0 plus 1, which equals 0. So I found the x-intercept and the y-intercept at the same time. So I get x equals 0, y equals 0. Okay, now I'm going to try and find, we know that there are no vertical asymptotes, so I'm going to try and find a horizontal asymptote. So I'm going to find the limit as x approaches infinity of x squared on x squared plus 1. And now that equals the limit as x approaches infinity. We'll divide by the highest power of x, which gives us x squared on x squared all over x squared on x squared plus 1, which gives us the limit as x approaches infinity of 1 on 1, I'm sorry, I forgot this x squared over here, plus 1 on x squared. Now realize we haven't changed anything. We just rearranged it. Oh, sorry, well, we've changed the expression, but we haven't, we've rearranged the expression. We've rewritten the expression. We haven't changed it. So now the limit's going to equal 1 on 1 plus 1 on 1 plus 0, which is 1. So I'm going to have a horizontal asymptote at y equals 1. All right, so now we're getting a bit of a better picture. So let's put our diagram in, and let's put our asymptote, and we know that y can't equal 1, so we'll put that in. And we know that it's an even function, so we really only want to have to concentrate on the positive side. We know it goes through 0, 0. Well, let's think about what happens as x approaches positive infinity. Well, what am I going to get? I'm going to get y is going to approach 1. We already know that, but from what side? Is it going to come from above or below? Well, let's put some numbers in. Let's put 100. Let's let x equal 100. Now, if I put 100 in there, I will get y will equal 100 squared over 100 squared plus 1. And that equals 0.99990, and it goes on. So that means it's coming from below that line. So I could pretty much say that this function is approaching from that direction. Now it's got to be a mirror image, so it's got to do it the same. Now I could pick some more points and see what happens. And here's the part where you're at a bit of a disadvantage at this stage. That is actually a turning point or a minimum value. Because of concavities, it's going to turn around. So that's y equals x squared on x squared plus 1.